this number, we're going to talk about the oxidation number basics. And we have to start off with the basic idea. And that is, of all the compounds in the world, very few are made up of charged particles, where you have 100% positive ions or negative ions, like sodium chloride or potassium nitrate, polyatomic ion. Most of the compounds are molecules and semi-molecules. No charges. So the problem is, how can we assess the activity or the action of these elements, individual atoms in the compounds? And the concept of oxidation number was invented. All atoms in all compounds in the world can be assigned oxidation numbers. The basic position is, we assume that the atom in the compound acts as if it were an ion. Now we're going to do a lot more than that with that definition. The whole definition has to be based on the idea of electronegativity. So we're going to put up the scale here in the corner in electronegativity. We're going to start with some rules. A simple rule is hydrogen, first rule, and let's use a different color here. The first rule, hydrogen in compounds is always going to be assumed to be the guy that loses the electron. In other words, it's going to be +1. Now notice right off the bat that this is a 1+ ion. Oxidation numbers reverse the sign. The second rule is oxygen in compounds is always going to get the electrons. It has 6, it would gain 2. So that makes it a very consistent rule, except for fluorine and another one, hydrogen peroxide compound. But these two rules are pretty solid, 1 and 2. And in keeping with chemistry, a simple 1, 2, 3. The third rule is all monatomic ions will be assigned the same number in the oxidation number, only they reverse the sign. And that's it. And of course we need to remember that all compounds are neutral, electrically neutral. So with these 3 simple rules, we're going to start doing some compounds. Let's start with sodium sulfate. Sodium sulfate. Sodium sulfate is an ionic substance, but we can assign an oxidation number. Sodium is in group 1. It is a +1 ion, and it will be 1+ ion will be a +1 oxidation number. There are 2, so the total positive is +2. Rule, oxygen is -2. There's 4, the total negative is -8. So let's do the math here. We have a +2 and we have a -8, and it must be equal to 0. So what is the oxidation number of sulfur? +6. Notice we delayed on trying to get sulfur. First of all, we had no rule on it. It was not monatomic. But it's easy to solve it by a little algebra. That the sulfur is the missing one. Let's try another one. Potassium permanganate. Rule. Potassium is a monatomic ion. It is +1. Gotta get this right color here. +1. Rule. Oxygen is -2. The more electronegative element. 4 times a -2 is a -8. So it's a minus 8 there, and that's a plus 1. Something here must equal 0. It is plus 7. We'll do a couple more. What about, let's see, calcium carbonate. Okay, calcium is in group 2. It's a 2 plus ion. It'll be a plus 2 oxidation number. Oxygen is minus 2. So you have a plus 2. 3 times a minus 2 is a minus 6. It must add up to 0. So what is that? That has to be a plus 4. And we'll just squeeze in one more over here on the side. Let's see, carbon dioxide. We'll end with a simple one. Carbon dioxide, a molecule. Rule, oxygen is minus 2. There's 2 of them, it's minus 4. Remember, all compounds must add up to 0. So the carbon here has to be, again, plus 4. So, oxidation numbers are going to be used a lot in redox equations and a variety of reactions. So it's very important to understand them. You should practice them. For additional help, I would recommend you go back to electronegativity on that session, look at that, or look at the oxidation numbers assigned in equations. And we'll stop right there.